In section 4.3, we're going to continue working with one sample t-tests for a population mean. And one of the main goals of this section is simply to get more practice working on these tests. The other goal is to introduce you to some details that are easy to miss the first time around. And in particular, one thing we want to talk about is this notion of a type 1 and a type 2 error in a hypothesis test. So this will go on kind of throughout this course. Anytime we do a hypothesis test, we could have a type 1 or type 2 error occur. And so I want to talk about what those errors mean, and really more importantly, the bigger picture of why we should be thinking about them and why we should care about them. And so the underlying idea of type 1 and type 2 errors is that statistics, and in particular statistical conclusions, are uncertain. So when we perform a hypothesis test, we're making a claim about a population from a sample, and we perform the test, we make a conclusion, and it could be that our conclusion doesn't match up with reality. So our conclusion might not match up with what actually is going on for the whole population. So our conclusion can be, and I'll put it in quotes, wrong, because it's important to understand I'm not talking about computational error. I'm not talking about bad study design that introduced bias or something like that. I'm simply talking about statistical uncertainty and variability. We can happen to get a sample due to pure chance, due to no fault of our own, that does not match up with what the population's doing, and we end up having a conclusion that is wrong in some sense. So this wasn't due to any sort of mistake. It's simply variability. And depending on what our conclusion was, the real world context of that error can be vastly different. And so this is the importance of a type 1 and a type 2 error. So a type 1 error occurs. And notice, I'll try to never say that someone made a type 1 error, because no one's making an error. It's a thing that happens, right? It's not a mistake someone's making. A type 1 error occurs when we reject the null hypothesis, but in fact, it's true. And a type 2 error occurs when we fail to reject the null hypothesis, but it's false. And depending on the situation, these errors mean different things. But important to keep in the back of your mind are these two things. It's not that someone's making an error. It's just a thing that will occasionally happen in statistics. But another thing, we never know if one of these errors occurred. I think there's 2 R's in occurred. That is to say, the whole point of statistics is we're trying to say something about a population that we don't have the ability to access, right? If we had the ability to determine whether we had made a type 1 or type 2 error, the whole exercise of doing whatever study we're doing would be pointless. The whole idea is that we don't know what's going on with the population. So we never know whether we made one of these errors. And so when we're looking at a research question, it's important to think about what would that error mean. So for example, one problem that we did in section 4.2 was we had this hypothesis test for a weight loss drug. And I want to think about, in context, what a type 1 error and a type 2 error would mean. So a type 1 error would occur if we rejected the null hypothesis. So in this case, the null hypothesis was that the drug did not help people lose weight. And so we conclude that the drug helps people lose weight. But it does. So that is to say, if we did this whole hypothesis test and ended up rejecting the null hypothesis, in the back of our minds, we'd have to think, look, it could be that there was a type 1 error here and that, in fact, this drug does not help people lose weight. And similarly, a type 2 error could only occur if we failed to reject the null hypothesis. And so if we failed to reject, we're not concluding that the drug doesn't work, but we're concluding that we don't have evidence that the drug works. So we conclude that there isn't good evidence that the drug works. And in fact, it does. Right? That is, we fail to reject the null hypothesis, but in fact, we ideally would have rejected the null hypothesis. Now, we should have. We did everything right. It's just our sample didn't match up with the population. So the thing to recognize here is that in any context, one of these errors or both of these errors might be bad errors, or maybe one of the errors isn't that scary. So I'm just going to like editorialize a bit and like make up some details here. But it seems to me that with a weight loss drug, a type 1 error would be a much worse error. At least it would be a worse error for the people who are trying to lose weight, right? There's plenty of weight loss drugs out there. I mean, there are other ways to lose weight as well. And so concluding that a drug helps people lose weight when it actually doesn't would be a bad thing. You would have people trying to lose weight taking this drug. Whereas concluding that the drug doesn't work when in fact it does, you're like, oh, well, that's kind of unfortunate, but that's not the end of the world. And so one of the things I like to think about in terms of type 1 and type 2 errors is understanding that we don't always have this symmetry with how we're willing to have our study be incorrect in some sense, right? So with a study of a weight loss drug, maybe we're a lot more worried about this. And so how do we deal with that? So, because I mean, you can't eliminate the possibility of either error, right? If you reject the null hypothesis, there always could be a type 1 error going on. If you fail to reject, there always could be a type 2 error going on. The thing you do have control over is the significance level alpha. Because the significance level alpha is your boundary for which p-values will cause you to fail to reject or reject the null hypothesis. If your level of alpha is low, you're requiring high standards of evidence to reject the null hypothesis. Or in my mind, you're saying, hey, we're trying to really avoid the chances of a type 1 error. Right? We really don't want to reject the null hypothesis unless in fact it's false, right? And if you have a higher significance level alpha, you're in some sense increasing the likelihood that you're going to reject the null hypothesis, in that you're requiring lower standards for your evidence against it. And so if you have a higher significance level of alpha, a type 2 error is in some sense going to be less likely. So this is how I think of type 1 and type 2 errors. You shouldn't memorize which is which. Right? You can always look that up. What you should do is you should try to understand why they matter, and in particular understand that our conclusions, just due to sampling variability, sometimes don't match up with the population, and we want to understand what that actually means in context.